Let's talk about quantum tunneling, which is one of those weird physics things that doesn't really make sense and yet is absolutely essential for our existence. Imagine you've got a ball and you're trying to roll it up a hill. If you don't give the ball enough energy, it's not going to be able to make it up and over the hill. But now let's imagine this ball is some microscopic particle and the hill is some potential barrier like the repulsion between two positively charged protons. Sure, this particle might not have enough energy to get up and over the hill, but sometimes it can tunnel and end up on the other side of the hill anyways. So how is that possible? Well, subatomic particles don't actually look like this. When we think about particles like electrons or protons, we don't visualize them like a little ball where we know everything about them. Instead, we talk about something called their wave function. Wave functions can tell us the probability that we will find particles at certain locations. So bringing it back to the hill, yeah, it's most likely that our particle here is somewhere on this side of the hill unable to get through. But there is a non-zero chance that the particle is actually over here. As you might imagine, the probability of tunneling depends a lot on the barrier you're trying to overcome. If this hill is bigger, it's less likely that the particle will make it to the other side. And even for small hills, the probabilities of tunneling are pretty low. But like I alluded to at the beginning, if this didn't ever happen, we would be screwed. Our sun shines because of a process called nuclear fusion, and in one step of that process, two protons have to get really close together. But protons are positively charged, they repel each other. There's a huge potential barrier in between the two particles. It is only through quantum tunneling that some of those protons can actually come together and fuse and the sun can shine. Without weird quantum mechanical phenomena like this, we wouldn't be here.